Alright, let's get started with 7.2, right triangle trigonometry. So we're going to talk about sine, cosine, tangent, all that good stuff in this section. Some of you might be thinking, what is that? A majority of you probably have seen that in geometry or in algebra 1. So let's find the values of trig functions of acute angles. So this is our old friend Pythagoras. The Pythagorean theorem is c squared equals a squared plus b squared, where c is your hypotenuse and a and b are the legs of a 90-degree right triangle. So just quick review. An acute angle means that you are less than 90, right? If you are bigger than 90, you are an obtuse angle. So we are not going to do any obtuse angles in this section. We'll deal with those later. Again, a right angle forms a 90-degree angle. And, a right triangle forms a right angle, 90-degree triangle. And similar triangles have the same angles in similar spots, but the lengths of their sides are going to be ratios of one another. Alright, so let's dive in here. So we have 6 trig functions. Sine, abbreviated SIN, which is b over c, better known as opposite over hypotenuse. Cosine, which is COS, which is going to be adjacent over hypotenuse. Tangent, which is opposite over adjacent. And then cosecant is the flip of sine. So cosecant will be hypotenuse over opposite. Secant is the flip of cosine, so that's going to be hypotenuse over adjacent. And lastly, cotangent is the flip of tangent, so instead of opposite over adjacent, it's adjacent over opposite. Alright, if we look at the triangle here, those fractions again, a good way to remember this is the mnemonic so, ka, toa. Sine is opposite divided by hypotenuse. Cosine is adjacent divided by hypotenuse. Tangent is opposite over adjacent. Right, so you can remember SOHCAHTOA, and then you just need to remember that cosecant is the flip of sine, which is kind of counterintuitive. You would think secant and sine would match up, and the co would match up with the co, but think about them as opposites. So you don't want to have a co with a co, you want a sine with a cosecant and a cosine with a secant. Alright? Alright, pause this if you need to get those down, but otherwise we're moving on here. Find the value of each of the 6 trig functions given a angle theta and 1 for the adjacent side, 6 for the hypotenuse. So first thing we're going to do is figure out the opposite side. So remember that c squared equals a squared plus b squared. So 6 squared is 36, a squared is 1, which means that b squared is 35, meaning that the opposite side here is the square root of 35. Alright, so let's knock out our trig functions. Sine theta is opposite over hypotenuse, root 35 over 6. Cosine theta, don't forget to write your thetas in there, that's a common mistake. Adjacent over hypotenuse. And let's do the flips. Let's do secant first because that's an easy flip. Secant theta is 6 over 1, or just 6. Cosecant is going to be 6 over root 35. Now you can't leave square roots in the denominator, so we're going to multiply top and bottom by root 35 and get 6 root 35 over 35. And lastly, for our tangent and cotangent, tangent theta is opposite over adjacent, so root 35 over 1, or just root 35. Cotangent will be the flip of that, which is 1 over root 35. Got to clean that up, rationalize your denominator, and you'll get root 35 over 35. All right, try problem 11. Second objective, we're going to use the fundamental identities, and we'll use those to solve triangles as well. So we know these already. Cosecant is the flip of sine, secant is the flip of cosine, cotangent the flip of tangent. But we can also add in here that tangent is sine over cosine, right? Because if we have sine as opposite over hypotenuse and cosine as adjacent over hypotenuse. If we divided those, the hypotenuse would cancel and we'd have opposite over adjacent, which is the formula for a tangent. So tangent is sine over cosine. The flip of that, cotangent, cosine over sine. All right, so find the values of the remaining trig functions given sine and cosine. Okay, so right away, we can go and get cosecant, which will just be the flip, which will be 10 over root 10. Clean it up. So root 10 times root 10 is 10, so those cancel. So cosecant is root 10. And your secant is going to be 10 over 3 root 10. Again, cleaning it up. That's going to cancel, and we'll have root 10 over 3. I think you're probably starting to see the patterns for flipping these over. We'll talk about that a little bit more later on. And lastly, let's get the tangent. So we know the tangent is sine over cosine, so root 10 over 10, divided by cosine or times the reciprocal, 10 over 3 root 10. Cancel, 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 cancel. Tangent is 1 over 3, which means that cotangent is 3 over 1, or just 3. Try problem 21. Okay, so if we know that b squared plus a squared equals c squared, if we divide everything by c squared, we'll end up with this here. And c squared over c squared is just 1. B squared over c squared is the same as b over c squared. And b over c is sine. So here's our first fundamental identity. Sine squared plus cosine squared equals 1. Make sure you have that down. We use this formula a lot. If we move things around, if we divide, starting from this formula, if we divide everything by cosine squared, we'll end up with sine squared over cosine squared, which is tangent squared, and 1 over cosine squared, which is secant squared. So second fundamental identity, tan squared plus 1 is secant squared. And by flipping those over, we can get cotangent squared plus 1 is cosecant squared. All right, so here's all of our fundamental identities. There are 8 total. Make sure you have all of those down. And we'll use those right here. Use the fundamental identities to find exact values. Don't need to use our calculator. We know that 1 over cosecant is the same thing as, what's the flip of cosecant? Sine of 35 squared. We put the squared before the angle here. It's sine squared 35 plus cosine squared 35. We know that sine squared theta plus cosine squared theta, as long as the angles are the same, this equals 1. What's cosine over sine? This is the same thing as saying cotangent of pi over 3 minus cotangent of pi over 3. That is just 0. All right, so we're just using our fundamental identities to cancel things out. All right, try problem 39. Objective 3, let's find the values of the remaining trig functions given the value of just one of them. All right, so if we're given sine is 1 over 4, so we've got 2 options here. First option is we're going to draw ourselves a nice right triangle, put in theta, and label some sides. Sine is opposite over hypotenuse. We know that this adjacent side is going to be c squared, 16, minus b squared, 1, so this is root 15. And now we're ready to go. We know our sine already is 1/4. From the triangle, we know cosine theta is root 15 over 4. We know that cosecant is the flip of 1/4, or 4. We know that secant is the flip of root 15 over 4, which is going to be 4 root 15 over 15. Right? Because I'm going to times by 15. And that'll just turn into a regular 15 if you flipped it over. Okay, starting to see the pattern. And tangent, opposite over adjacent, 1 over root 15, which will be root 15 over 15. And then cotangent, root 15 over 1. All right, we've got them all. So, couple options here. Method 1 is to use the definition, drawing a right triangle, and then we've got 2 of the sides, so we can figure out the last side, and then we just plug all the sides in. Method 2, which we'll do right now, is to use the identities. So let's see here. Tangent theta equals 1/3. All right, so the identity we have that has tangent, we're going to want to use tangent squared. Plus 1 equals, if you go back to your trig identities, tangent squared theta plus 1 equals secant squared theta. All right, so 1/3 squared is going to be 1/9 plus 1. So that's 10/9. That equals secant squared. Square root, we get root 10 over 3 equals secant. All right, if we know tangent, we also know cotangent. That's just going to be the flip of that, is 3. If we know secant, we know cosine, which will be 3 over root 10, or 3 root 10 over 10. And now we need to get sine. So let's use our, how about the cotangent formula? We know that cotangent squared theta plus 1 equals cosecant squared theta. All right, so 3 squared is 9, plus 1 is 10. So 10 is cosecant squared. So root 10 equals cosecant. The flip of that is root 10 over 10. That equals sine, and we've got them all. All right, so 2 methods. You can use either one. In this problem, it probably would have been easier to draw the triangle, but I wanted to show you the other option. Here's our triangle. Tangent is opposite over adjacent. And then we know 1 squared is 1, 3 squared is 9, so this side would be root 10. There's all those root 10s that we've been seeing throughout this problem. All right, try problem 25. Objective 4, complementary angle theorem. So, if we draw ourselves a triangle, and it's a right triangle, we know that in any given triangle there's 180 degrees. If we have a right angle, we have 90 degrees left for the other 2 angles. So those other 2 angles, call them alpha and beta, have to add up to 90 degrees. So we know that if we know A, it's going to be 90 minus beta. Beta is going to be 90 minus alpha, right? The 2 angles have to add up to 90. So that's what this is saying here, right? The sine of one angle is the cosine of the other angle, since they have to add up to 90. So the sine of 30 is the same as the cosine of 60. 30 plus 60 is 90. Tangent and cotangent are going to be cofunctions, and secant and cosecant are the matching cofunctions. All right, so here's the list. You can get them all down. You can write this whole thing down, or you can remember that sine matches up with cosine, tangent matches up with cotangent, and secant matches up with cosecant. Here's that list one more time. Pause the video if you want to get the whole thing. All right, so let's finish up here. Use the complementary angle theorem. What's the same thing as saying sine of 47? 90 minus 47 is 43. So that's the same as saying cosine of 43. Tangent of pi over 8. Well, what's 90? 90 is the same thing as saying pi over 2. What's pi over 2 minus pi over 8? Let's get common denominators. So this is going to be the cotangent of 3 pi over 8. What is pi over 2 minus pi over 3? Common denominator would be 6. And so we'll have pi over 6 with cotangent, complementary angle of cosine is sine. And pi over 4 plus pi over 4 is pi over 2, so secant complementary to cosecant of pi over 4. You'll get the same thing. All right. Let's try one more thing. You'll have one more problem, and then we're all done here. Cotangent of 15 is the same thing as 90 minus 15 is 75. The same thing as tangent of 75. Tan 75 over tan 75 is just 1. Cosine 38, what's 90 minus 38? 52. So cosine of 38, which is the same thing as saying sine of 52. Look at that, they're going to cancel. We've got 0. All right, try problem 43. Your job there is done. Any questions, we'll go over them in class. Good luck.